Okay, good morning, good afternoon, everyone. I am Tony Paraday from Worldline. I'm the coordinator of the Bloomen project. Bloomen is a project which is co-financed by the European Union under the Horizon 2020 program. The project is quite close to the end, so we are organizing this Bloomen Week, in which we are presenting and sharing our experiences during this time with you and with several experts in the field. So we have organized a day dedicated to photos, another one dedicated to music, and today, which we are devoting to video streaming and how blockchain technology is applied to this sector. So for this, we have today as moderator of this session, Michalis Odysseos from Antenna, who is going to moderate this session. So Michalis, the floor is yours.
Hello. So thank you for the introduction, Tony. As you said, today is part of the Bloomen Week series of events that we are organizing for the final stages of the project. Today, on Monday, we had the photo day. Yesterday we had the music day, and today we're gonna have the video day. And that doesn't necessarily mean that we're only gonna talk about video. Blockchain is a broad such subject that many people want to hear about and want to learn about. So today's event has complementary sessions that include other speakers. If we go to the next slide, we'll see that we're gonna have Theodosis Mourouzis from Electric Consulting. This is a PhD from UCL. He has great experience in cryptography, in privacy, and he's been involved in highly prestigious projects and the research and also practical applications with blockchain. Also, we're going to have Professor George Yaglis from the Institute of the Future from the University of Nicosia. Professor Yaglis, everyone knows Professor Yaglis. Everyone who's in the blockchain space knows about him. He has also been a bit involved with our project. He in terms of consulting us about specific topics, and he's gonna talk about CBDCs. These are central bank digital currencies. This is also an area that we have been experimenting with from within the research project. Privacy was one, and the second one was digital currencies that could be potentially issued by central banks. Both topics are really important for us, and also I assume for the people who are attending this webinar. And then I'm going to be presenting about the implementation that we did on a live environment with Antenna in regards to using blockchain technology for managing, distributing, and providing access to audiovisual content protected by copyrights. I'm going to do a very short demo, so we don't take a lot of your guys' time. And finally, we're going to have a Q&A session. We're going to be able to respond to any type of questions. Moving forward, just a tiny note. Participants, apart from the panelists, are going to be always muted with the camera disabled. Of course, your written questions are welcome. You are welcome to ask anything you like, whether it will be during the presentations or afterwards during the Q&A session. And please note that this session will be recorded. Doesn't mean that it will be released into the public, but it's possible that at least a few segments are published online for the purposes of providing this content more publicly. Of course, your participation and questions are private. You can point the questions towards either the panelists or the full audience of the webinar. And okay, first I want to hand over to Mr. Theodosis Moroutzis, who is going to be presenting about privacy preserving techniques in the DLT space. Theodosis had some audio issues with his microphone. I think he's with us, but if we're not, we're going to proceed to Professor Georglis and then return to Mr. Moroutzis. Theodosis, are you with us? No. Just give a moment to Mr. Moroutzis.
Hi, this is Theo. Can you hear me?
Yes, we can hear you perfectly.
Okay, I'm just calling from like dial-in, because there are some issues here connecting with this GoToWebinar. Can you see my slides, or I don't have a permission now?
I will make you a presenter right now. One moment, please.
Hopefully, it's gonna be okay.
Okay. Okay.
Can you see it?
Not yet.
One second. No, I have to reconnect. I have to reconnect for a bit.
Okay.
You can still hear me, right?
We cannot see your slides, but
yeah. One second.
Yeah.
What about now?
Not yet, fortunately.
Can you see the slides now? Yes, no?
Not yet. 1 second. Can you try again now?
Yes. What about now?
Yeah. We're good now. Thank you.
Okay. Let me know if it's okay to start. And apologies for this.
No worries. You can start anytime you like.
Okay. So I'm going to discuss about privacy preserving tools for blockchain, which is like a quite popular topic at the moment. So my name is Theodosis Moroutzis. My interests are in cryptography and blockchain technology. My background is in mathematics and cryptography, having been at the University of Cambridge and then at UCL. And at the moment, I'm running my consulting firm, Electi, where we have been working with different like big organizations like US Navy, European Central Bank, and MSC Ship Management on applications of blockchain technology for different like problems that they face. And also, I was among the team members that have co-authored the blockchain strategy for the Cyprus government. At any time, if you can't hear me, just like ping me, okay? So.
Yeah, it's all good.
Electric consulting, okay. So our target as a consulting firm is to use AI, blockchain, and cryptography in order to help our clients to reach their potential and use this technology not just from the hype and buzzwords point of view, but just do the real application and show the real impact. And here are some of our clients, okay? So what I'm going to discuss today, I'm going to discuss why is privacy so important in blockchain, and I'm going to discuss several techniques that are being deployed for guaranteeing privacy on the blockchain space, like mixing techniques, zero-knowledge proofs, homomorphic encryption, and something that is quite popular at the moment called like Zcash techniques. DLTs and blockchains look very good. They have very nice features like accountability and transparency. Everything is legit there. You can go and see the transactions. You can go and like query and see a full life cycle of a transaction. Everything is transparent. And this is because of the idea of the public ledger. That is the backbone of like the blockchain ecosystem and keeps track of all the approved transactions. In a sense that you can like query and see transactional data and see exactly how transactions flow within the network. And also you can also see if something has really been approved by the owner of the funds and if has been accepted by the recipient. So we have also this non-repudiation aspect, which is guaranteed by the digital signatures, and it says that there is guarantee that someone has authorized the transaction. Tracking is linked to transparency to a very high degree. So, like for example, the Bitcoin network, you can go and see the public addresses there, and you can go and see what are the transactions that these public addresses have performed and where they have authorized their funds to be transferred, because everything is like hosted on the public layer. Bitcoin, for example, stores data about user balances based on the unspent transaction output model, the UTXO model, and any transaction has to refer to some previous unspent transaction. So by just going over this logic, it means that each time you can track and see what is the chain of the transactions. Okay, so it's like this, which means that you have a nice representation of transactions and you can query them at any time and see the exact details. For example, which public address has sent what amount to another public address. So the problem here is that there is no transactional privacy if we follow this model, because all the values of the transactions are pretty much like revealed. And if you do start doing some clever things like using several addresses, either from the origin or from the receiver side, you still see the values there, which is something that you might not want to actually reveal because you want to have some anonymity or privacy. And anonymity and privacy at the moment are biggest challenges in the blockchain and DLT space. And as a professional cryptographer, when I talk about anonymity and privacy, I'm not talking about cheating and hiding the values. I'm talking about a concept where I want to have my full privacy and anonymity in a way that things can be verified that are being done in a very legitimate way, but not the actual values being revealed. It sounds like magical, but there are techniques that are being deployed nowadays in cryptography, and they can verify that the transaction is valid without actually revealing transactional like inputs like origin, recipient address, also the values of the transaction. When Bitcoin revealed, the researchers started immediately to try to break this pseudo-anonymity. Pseudo-anonymity because clearly in Bitcoin there is no anonymity. Like we have the public addresses, which means that everything can be linked to different public addresses. So it's like being hidden behind like a string of a string value. So we have a paper by Barcelo saying that user Bitcoin transaction can be linked to reveal users information, 2014. And several other researchers tried actually to uniquely identify clients behind the nodes by just seeing transactional data. And a very popular paper that came out of UCL research that said that it's possible to link addresses to the user's real identity, as many users make transactions with the same address frequently, even though there is some pseudo-anonymity kind due to the public address. So all these research statements that said it's okay to have like a public ledger, but still there are issues with privacy and anonymity, they actually made the cryptographic community to start developing techniques in order to guarantee the privacy and anonymity of transactions. And in general, we have different categories of techniques that can be used in order to guarantee these properties that we want. Mixing, anonymity, and homomorphic encryption are main techniques that can be used across the different properties that we would like to guarantee. What is mixing? Mixing service is a kind of service which provides anonymity by transferring funds from multiple input addresses to multiple output addresses so that tracking becomes computationally difficult. What does this mean? It means that you put all the input addresses into a mixer, and then instead of having a direct link shown on the ledger, which input goes to which output, there is like a lot of intermediary states that make sure that you cannot identify which transaction went to which output transaction. Then we have like techniques based on zero-knowledge proofs that can guarantee anonymity, like Zcash techniques used to hide both origin and destination transactions, transaction amounts, and the values of coins held by users. And something quite popular at the moment, homomorphic encryption, which means that you can encrypt your data and perform computations on encrypted data and still verify several properties without actually knowing the content, which means that using homomorphic encryption, I can prove that I have some funds above a given bound without actually revealing this value exactly what it is. Example of mixing, let's say Alice with address A would like to spend some funds to Bob with address B. And if Alice, for example, says directly this transaction from address A to address B, it means that these transactional data are being revealed and hosted on the ledger, which you can query them. So instead of Alice sending these funds to a trusted intermediary to Bob, she sends these funds to like Carol. a third party that sits in the middle, which means now things become more complicated because Carol has the property of collecting different transactions and then relaying them in a shuffled way, which is what is shown here. Mixer receiving lots of input transactions and then mapping them into output transactions so that the correct transaction took place, but in a way such that you cannot really identify who sent to whom the money. So initially, if you are in the Bitcoin space, you have seen many mixers, but most of them have been taken down at a later stage because of illegal activity, money laundering activity. But these mixing techniques can be based on something called proxy encryption stuff if you want extra security. And the basic idea is based on like shuffling the transactions in a way such that they cannot be queried at the later stage on the public ledger. So what is the problem with like these mixing techniques? What about the intermediary being dishonest and reveal Alice and Bob's private information on purpose or transfer Alice funds to her own address instead of Bob's address? So what about if this mixer is not acting in a legit way as we want? So we can have like other techniques like sequential mixing or central mixing servers for shuffling out addresses, or decryption mixnets using proxy encryption techniques, or even ring signature mixing. So we can have more advanced constructions of these simple ideas you see here that can increase the level of security that we have in terms of the mixnet being like acting in a legitimate way. Which cryptocurrencies today are using these techniques like Mixcoin, Monero, and also the Aztec protocol for Ethereum is planning to use such techniques. So other techniques that we can have is like on the sender's privacy, we can apply ring signatures and zero knowledge proofs, meaning that instead of signing a transaction, you can put this transaction into a pool of other signatories, and then all together they're going to sign all the transactions, which means that they cannot see who sent the money who, because how you can check if someone sent money to someone, it's by checking the digital signature of the transaction if it's valid. And receiver's privacy can be actually guaranteed with some techniques called like stealth address mode or method or blind signature, which means that each time you receive new transactions, you can have different address to map these transactions and obfuscate a bit where the transactions actually are directed at the end. What is the problem with mixing? In order for this technique, and in general for the most of the privacy and anonymity preserving techniques, in order to be functional, then you need like a critical mass to adopt the system. Otherwise, it's like being hidden behind your finger. What do I mean here? If I have a ring signature, which means that I have a group of people that all together decide to sign the transactions instead of each one using their wallet, it means that if there are just two people or one people, I mean, there is no security. You need to have a lot of people so that a lot of obfuscation of data is happening. Another technique that is being applied is that of zero knowledge proof, which is a quite complicated technique in cryptography. So the idea here is that Alice would like to prove something to Bob, for example, that she knows the password of the bank statement, but Bob is asking, show me the direct inputs in order to be convinced. And the idea is that Alice would not like to show the inputs, but she would like to convince Bob that she really knows this data, like password or bank statement. Or for example, she really knows the secret key that can be used to sign a transaction, or she really knows how many funds she has in her wallet. But the idea is that she would like to convince Bob that she has this amount of funds, with not actually revealing this amount. So, and this comes with the idea of the zero knowledge proof. Zero knowledge proof is like, it's the idea of proving that a statement is true given a witness without actually revealing the actual content. And we have like a prover and verifier and several communication taking place among these two parties in a way such that they can prove that something is correct. For example, that Alice holds 5 Bitcoins without revealing the value of 5. So this is pretty much the idea behind the zero knowledge proofs. And we would like zero knowledge proofs to be robust and sound in a way such that it's very easy to verify transactions without viewing them exactly what their values. And zero knowledge proofs and homomorphic encryption is something that is combined together in order to achieve a statement of the form A would like to send to B X amount of Bitcoins in a way such that both addresses are being hidden and the value is being hidden. And this is in order to be guaranteed, we need to combine zero knowledge proofs with like types of homomorphic encryptions. What is homomorphic encryption? Homomorphic encryption is like a form of encryption that can allow computation on ciphertext, which means that you can do several tests on the ciphertext space, which means that instead of viewing actual data, you can view encrypted data and still do computations on this encrypted data. Okay, and this is like a very, very like important problem and challenging problem in cryptography. It's like the holy grail in cryptography nowadays. We don't have fully practical homomorphic encryption schemes, but we have like variations that can be used in order to guarantee specific properties. For example, we have several cryptocurrencies, we have several protocols like the Aztec protocol and on Zcoin that are using some type of homomorphic encryption that can be used in order to encrypt transactional data in a way such that you can still work on the encrypted version of them and do inferences as you want for consensus. Okay, and semantically, it looks like this. Instead of working on the message space, let's say M is a full transactional data, origin, sender, and the amount. You work on the encrypted versions of them, and you can still do inferences. And this combination of several like novel techniques in cryptography, like multi-party computation with like zero-knowledge proofs and homomorphic encryption, is called something Zk-SNARKs. And Zk-SNARK stands for zero-knowledge succinct non-interactive argument of knowledge, which is a very new technology that is being applied by Zcash protocol. And the idea here is that you can still verify the transactions. The miners can verify the transactions without viewing any content regarding who have sent what to whom, okay? And this is an important thing. We can achieve that we have legit transactions and at the same time guaranteeing privacy and anonymity. And Zk-SNARKs is using like by Zcash at the moment, Aztec and Komodo protocol. And some anonymous currencies that we have at the moment, like Monero is using ring signatures, Dash is using, which is fork of Bitcoin, using coin mixing services. Zcash is using Zk-SNARK or zero knowledge proofs. And Birch is using like Tor and IO2P network for privacy. Komodo is using like Zk-SNARK protocol. And PIVX is using like the zero coin protocol for achieving like anonymity and privacy. So what I would like to mention here is that in cryptocurrency space, blockchain space at the moment, what is the holy grail? The holy grail is to build like efficient protocols that can be used in order to proper verification of the data flow into the ecosystem, meaning that we can verify transactions, but at the same time keeping like privacy and anonymity of the transactional data. Okay, so this is from my side. I try to not to be very technical, but keep stuff in the middle so that you can go later and see if you would like to search more on specific techniques that are being used in privacy space.
Okay, thank you very much, Theodosi. Fantastic presentation. We'll see if there are any questions now. Otherwise, we'll proceed to the next presentation. No questions. Okay, so now we move on to the presentation of Professor Georgia Yaglis, from the Director of Institute of the Future from the University of Nicosia. 1 second. Okay. Yes, Professor? Professor, can you hear us?
Okay, hello everyone. I can hear you. Can you hear me now?
Yes.
Super. Can you also see my slides?
Now it's a blank screen like before. I think you have to share your screen instead of the window. That's the only way.
Okay, let me try that.
Not yet.
Okay. What about now? Is it showing now?
Yes. Now it's perfect.
Okay, great. Great. So hello everyone, my name is George Yaglis. As Michalis said, I'm the Executive Director of the Institute for the Future at the University of Nicosia. The Institute is an independent research center at the university, bringing together all our activities around blockchain, cryptocurrencies, artificial intelligence, and other technologies that belong to what we call the fourth industrial revolution. And in this talk, I'm going to focus on one of the aspects that I consider very important for our future, and this is central bank digital currencies. And I will focus on this for two reasons. One is that I think it represents a very transformative moment. So from the moment that our central banks start issuing digital currency that mimic some of the properties of the cryptocurrencies as we know them, we'll be talking about a wholly new architecture for money that's going to be changing everything regarding how our economies operate. And the second reason that I chose to do this is because I think it is a subject that is often mischaracterized or misunderstood by the cryptocurrency community. So we do lots of educational activities at the university. We run the world's first master's degree in digital currency. We do a number of professional training courses, and in many discussions I've had, not only with students but also with senior professionals, they seem to think that CBDCs are another form of Bitcoin or some other type of cryptocurrency, with the difference that they are issued by the central bank. So in the next 20 minutes, I'm going to do a quick presentation. I will try to keep it at a very high level, so we're not going to focus into any of the technology details, just to make sure that everyone is clear about what this is and why it is important. So to start with, we need to understand that the type of money that we hold today, broadly speaking, can fall into two categories. We've got physical money, so banknotes and coins that we hold in our pockets, and digital money. Effectively, most of this is ledger entries in accounts that we keep with banks or other financial institutions. What needs to be understood, and I'm not sure that many people understand it, although they use physical money all the time, is that these money are issued by the central bank. So the only institution with the authority to print euro banknotes or mint euro coins in the Eurozone area is the European Central Bank. And every time a European citizen holds a euro note or a euro coin in their wallet, it is the only type of central bank issued money that they hold. All the other money that they hold in digital form, they are held with commercial banks or fintechs or other financial institutions, and you cannot go as a citizen or as a business to your central bank and ask to open an account for you. The only institutions that can hold accounts with the central banks are the commercial banks themselves. So the architecture of the monetary system today, simplistically, looks a bit like this. So on the left, we've got the general public, every one of us that have our so-called balance sheets. So we've got our assets and our liabilities. We have monetary relationships with the commercial banks that have their own balance sheets, and they have their relationships with the central bank, and everything that is an asset to one party becomes a liability to another. So if I take a loan from a commercial bank, then this loan is my liability and it is an asset as shown in the balance sheet of the commercial bank. The only direct relationship between the left and the right part is when we hold physical currency. So coins and banknotes that I held as assets are liabilities of the central bank that has issued them. But these can only be in physical form. A central bank digital currency would effectively be what the name suggests. It would be a currency that sits in the middle of this so-called money flower that you see here. And sitting in the middle means that it holds all four properties that this money can hold. So it's a form of money that is issued by a central bank, like cash, for example. So it belongs to the blue circle that you see there. It's a money that is electronic, so it belongs to the green circle, like, for example, cryptocurrency. It is something that is universally accessible, so as opposed to, for example, wholesale forms of money that are used only for interbank clearing transactions. This is something that everyone can use, households, businesses, financial institutions, and so on. So that's the red circle. And finally, the yellow one is that this is peer-to-peer money. Again, like cryptocurrency, it can be used for exchanges between holders of the money without the need of any intermediary to facilitate this transaction, as opposed, for example, to deposited currency accounts. So a CBDC, retail CBDC, would be a new form of digital money that is issued by a central bank, that can be held by households and businesses, and can be used to store value and make payments and be a legal tender in their jurisdiction. So it will be, in cryptocurrency jargon, it will be a stable coin. A stable coin by design, it doesn't need to be pegged to anything because it will be pegged to itself. So if I hold 50 euros of an ECB issued digital currency, this will always be the same as 50 of physical money issued by the central bank, and there's nothing, not a physical commodity or a algorithm needed to maintain this peg. It will be so by fiat, by design. So if this is what a CBDC is all about, why is it being discussed so much? Well, what's the innovation? And I think there are two flavors in this innovation. One is that CBDCs will create a new form of money that will be natively digital. It will be born and exist only in digital form. It will be, as opposed to cryptocurrencies of all sorts, it will be legal tender. So by definition, it will fulfill the most important function of money. So it will be a means of exchange for people. You could go to your supermarket and pay for your bill with this digital currency, and the supermarket will not be able to refuse being paid in it more than they can refuse being paid in banknotes or coins. And it will also, as I said, be stable by design, so it will always perform the second most important function of money, which is being a store of value. So the idea is that, again, as opposed to cryptocurrencies, here we have something that from its very first day is a great means of exchange and a great store of value. So it's a wholly new form of money. But the most important stuff is that it incorporates these two basic functionalities of money while adding many of the very interesting features of cryptocurrencies as we know them. Some of them might be related to privacy, like Theodosis mentioned before, but also programmability, the ability to write computer code that is attached to money and makes it behave in an active sort of way based on the instructions given to it by its owner. The ability to execute smart contracts, so self-executable and self-enforceable pieces of code that force the contractual obligations between transacting parties. And these transacting parties do not necessarily have to be humans. It can also be software or machines or objects that would be able to form on-the-fly smart contracts between them and use this type of digital money to assign services to each other and pay each other for these services, thereby paving the way for an era of what I would call machine-to-machine commerce, and also execute nano payments that can be denominated in hundreds of millions of a single unit of the currency, something that cannot be done with the money that we have today, and is only possible with cryptocurrencies, which, however, do not have the CBDC functions of being, stable by design and legal tender. So that's one let's say, group of properties of CBDC that makes them extremely interesting for our future. But on top of being a new form of money, CBDCs also create a new infrastructure for payments. Today, most of the payments that flow in the global commerce settled between central banks and commercial banks flow through what we call real-time gross settlement systems, or RTGS. These are very slow to innovate, very monolithic and very centralized architectures, whereas a properly designed CBDC will create a new type of distributed network that will enable an open and neutral payment architecture, open to anyone to innovate, provide additional services, foster competition, and thereby help us tremendously go to the second wave of digitizing our assets, which has started in the 2010s with Bitcoin, Ethereum, and all the other types of digital currencies. And now we're moving more to a full tokenization of all types of financial assets, not only including money, but also including illiquid assets like, for example, real estate, or even things that could not be traded before, like one's future income or even. The next question would be, why now? I mean, okay, these may be super important innovations, but what is driving the current flow of interest around them? And I think there are three types of forces behind the discussion around CBDCs. One is market forces. We have a combination of both demand and supply pushing towards the implementation of CBDCs. Demand is driven by the ubiquitous and pervasive nature of digital payments. We've seen a move over the past 20 or 30 years from physical money to card-based money, and then to digital accounts, and then to mobile. And we've now reached a situation in which, in many countries, payments flow digitally throughout the spectrum. So if you take, for example, countries like Sweden, less than 1% of payments now take place in form of physical cash. If you take giants like China into account, around 16% of the GDP of China is now going through the systems of two mobile payment providers, so Ant Financial and Alipay. At the same time, Bitcoin, Ethereum, Litecoin, Ripple, all the innovations that we've seen in the past few years have shown that the technology is there, is mature. It can be used to build secure global systems of real-time or almost real-time monetary value transmission, clearing, and settlement of transactions. So the combination of the ability to implement such things and the need to have such things is the first driving force for CBDCs. The second one is, as always, competition. There's private providers that are issuing their own forms of digital money. You all have heard about Facebook and Libra and their newly renamed Novi wallet. And if you were a central bank central bank, or if you were a government, you wouldn't want probably Facebook or another private player to be the world's reserve currency for the digital age. You would like to do that yourself. So competition with the private sector is pushing central banks to implement these things, and there's also competition between each other. There's even geopolitical issues here, because the internet age will require some native internet money. This internet money will be probably developed not by the private sector, even if we are all, very in favor of things like Bitcoin here. we need to acknowledge at least the fact that institutional players always have a huge say in these things. So the first central bank that will create a successful CBDC will be a strong candidate for the world's reserve currency for the digital age. So if you've got China building their own CBDC, then obviously the ECB or England or the Fed in the United States will follow suit. And finally, even the current situation with the COVID-19 is also playing its role, because the central banks are looking for ways in which to implement monetary policy to get the world out of a recession that is inflicted by COVID-19. And one of the things that they're doing is what we call asset purchase schemes, which is effectively means inflating their balance sheets and printing new money. Printing new money is very archaic if you do it by actually literally printing the money. So they're not actually having printers generating new banknotes out. Effectively, what they do is something that is semi-archaic. They are purchasing bonds, which be either government debt or financial institutions debt or even corporate debt. And in this process, they are creating new money indirectly. If you had a CBDC, you would be able to implement what we call helicopter money policies in central bank jargon. In cryptocurrency jargon, you may have heard this as airdrops. So you would be able to actually distribute newly issued money directly to the population without needing to have the financial institutions or the banks intermediating this. So in a period of interest rates that are close to zero, if not outright negative, the central banks need weapons through which they can implement monetary policies more effectively to mitigate crises, and CBDCs are a potential weapon towards that direction. And regarding our main question here, whether a CBDC is a cryptocurrency, the short answer is no, it's not. There's no necessary connection between the currency and the technology through which it is implemented. So in other words, there might be what we call decentralized CBDCs, the architecture of which sounds a lot like the architecture of cryptocurrencies, but there could also be many advantages to having centralized architectures, since you've got the central bank as the issuer and destroyer of tokens in the CBDC. So maybe they would like to opt for a design in which the nodes are not peer-to-peer and equal like they are in the case of Bitcoin or other cryptocurrencies. And maybe you would not want to have such a hardwired monetary policy mechanism embedded in the code of the currency. You would like to keep some flexibility and some decision making for the central bank. So in other words, a CBDC could be a cryptocurrency in the sense that it's using decentralized networks and cryptography to implement its functionality, but it could also be built using other technologies that are not mimicking this architecture. So if you see this table that tries to compare Bitcoin with CBDCs in a number of dimensions like monetary policy, storage, transfer, stuff like that, you will see that in the case of the CBDCs, everything is or could be determined by the policymakers, and this would be the central banks or whatever. Whereas in Bitcoin, everything is fixed, determined, hardwired into the code, and cannot change unless a majority of participants in the process decide to change it. And this is not always easy, as we have seen in the last 10 years. So you might want to have a more centralized design. Do they exist yet? Again, the answer is no. We don't have any fully functioning CBDC at the moment, but they are coming. So according to the Bank of International Settlements, 80% of the world's central banks are exploring CBDCs, and 10% have already embarked in pilots. I think at least judging from what has been announced, China is the one that is ahead in this game. Last month it started even testing in 4 cities with 19 partners its own version of CBDC. They call it DCEP, Digital Currency for Electronic Payments, and they have issued units of this currency to some government officials in order to pay for transport in these 4 cities. So they're quite ahead in implementing it. Sweden is another example, and Sweden is a blockchain-based CBDC. As you can see here in China, although they're using asymmetric cryptography and smart contracts, they are not technically speaking a distributed ledger-based currency. And the final question I'd like to address is what's stopping it from launching? Why are central banks so cautious in launching this? And the reason is that obviously, if you want to change the global monetary architecture, this is not an easy task to do and not something that should be taken lightly. There's a number of questions that need to be answered, and the questions range from those that are more technology or architecture oriented to those that are more policy oriented. So I've got a collection of such questions here. So for in the architecture domain, do you want your CBDC to be token based or account based? In other words, do you want it to look and feel more like Bitcoin or more like bank accounts that users are used to? Do you want it to be centralized, as we said, decentralized, more like cryptocurrencies, or hybrid, like the architecture in the diagram that you see in this slide, which comes from the Bank of England, and they are designed for a CBDC? Will it be blockchain based or not? What's the underlying security protocol? How are you going to implement access restrictions to this? Because obviously, if you are the central bank of China or Fed or whatever, you don't want to create a global currency, so you need to have a mechanism through which, even if it is cash-like and purely anonymous, to have it available only to the citizens and businesses in your jurisdiction. How are you going to do that? Is it going to be interoperable with other CBDCs? So are we going to end up in a bubble tower in which each central bank is doing their own thing and inter-country transactions are going to be difficult to facilitate, or do we all adopt the same standard? Policy-related questions. How is the token going to be issued, and how is it to be distributed to people? What will stop me as George from creating thousands of wallets and claiming newly minted currencies in each of them? What will be the total monetary supply? Will there be controls? Will there be, for example, thresholds in how much digital money each of us could hold? What about privacy and surveillance type of implications? The more anonymous you make it, the easier it will be to be used, but the more it could be used also for criminal activities. The more you opt for regulated implementations in which it will be easy to do KYC or AML or other stuff, the less privacy is guaranteed for the citizens and the users of this money. Also, will the new currency be remunerated? In other words, will it carry interest like our bank account deposits, or will it be a non-interest bearing instrument like our cash? What about systemic risk? A central bank cannot go bankrupt by definition. They can always print their own money. So even at the hint of a recession or financial trouble, maybe people will do bank runs and take all their money from the commercial banks and move it to the central bank. How will you avoid that? What about social inclusiveness? How will you make sure that everybody, regardless of whether they are senior citizens or not technology literate or even handicapped or whatever, will have equal access to the money? And finally, what about offline use? If we move to a world in which everything is digital, what happens if we get into a cyber war or an accident and some natural disaster or enemy takes our internet infrastructure down? Does this mean that the global financial system will be taken down as well? Because it's one thing doing without information flowing around the world for a number of hours, and another thing without money being able to be transacted. So there's a number of challenges to be resolved, and this is the reason why I think this is a very fascinating topic that will be the subject of core discussions in the cryptocurrency community in the coming years. Thank you very much for your attention.
Thank you very much, Professor. Always, it's fascinating indeed, and it's always a pleasure watching your presentations. So now, next, I'm going to be presenting about our work within the Bloomen project in regards to video and blockchain. Let me share my screen. Okay. Yes. So my presentation is called a migration to centralized OTT media services because our company is a traditional TV company, but we are researching and exploring possible pathways to still maintain our production, increase our production further, and then find another ways to reach the audiences apart from the traditional TV sets that everyone has in their homes, but nowadays are using for other things like for over-the-top platforms or gaming. So we have to find a way to reach these audiences, especially the younger audiences, through other means, other platforms as well. So a few words about myself. I'm the digital development manager for Antenna. It's a TV company operating in Cyprus for 27 years. I also have just finished my master's degree in digital currency from the University of Nicosia. I'm also actively involved in the community, in the crypto community in Cyprus. And yeah, this project was a fantastic opportunity for our company to participate in a European level with other very big partners in the project. So, okay, I'm going to talk about some challenges businesses such as ours are facing in the current age. These are attributed to the company itself operating in the specific market in Cyprus, but also as an industry, there are also some challenges, big challenges that have to be faced. And while I'm talking about this, many of you who know about a few things about blockchain technology will start to think why I'm mentioning these challenges. So Antenna is a small player, small company in Cyprus that faces often it used to face many challenges in purchasing copyrighted content, let's say purchasing from Latin America or the United States. As a small player, you don't have all the opportunities that you would like to have when dealing with this business. It's also very expensive to maintain VOD systems. Video on demand systems are very expensive to maintain. You have to upgrade on a per year basis. We face GDPR challenges, of course, high transaction costs. If you want to implement a premium service, then you have to consider, let's say, this is not a definite number, but like you have to be able to say that 20% of your proceeds will go to transaction costs or third-party commissions. Of course, geo-blocking can be a challenge. Most of our productions are meant to be broadcasted in Cyprus, but the people, the viewers, do not like this situation very much. it's also something the European Union is pursuing after, like eliminating the geo-block restrictions, at least when it comes to members of the European Union. And the industry as a whole, we talk about the current state of art being too centralized. As in regards to the OTT services, there are some companies like Netflix, Amazon, Hulu. These players are very strong, and they pretty much can't decide who is going to be reimbursed about copyright content, and what is a fair amount of compensation these people should be getting. Generally, artists we have spoken to do not like these very centralized businesses dealing all of their copyright content, how they should be compensated. Of course, this leads to monopolistic practices. Strongly centralized companies, they can decide how much people should be paying and how much these copyright owners should get paid. They often become a target of hackers. This has happened 4 years ago or something, when we had this huge hack of Sony. Because of that, people say that was from North Korea because they made a movie about that. So who knows? But really, with strongly centralized actors, then the more centralized, the bigger the companies, the more ideal as a target it becomes for hackers. It's also very expensive to do due diligence. The example I always say about this is when we had the bank haircut on deposits in Cyprus a few years ago. Dealing with outside of Cyprus, and especially outside of the European Union, became really difficult for our businesses when they didn't know, like a business in the United States did not know if you can really afford to pay for copyright content to license that content. They say, do you really have the money? Because we don't know what's the situation now in Cyprus. Some of this, and the counterparty risk, of course, not knowing if one party can fulfill their contractual obligations. All these are some challenges that can be addressed with blockchain technology. Some of them we deal within their projects, some of them not, because they're too broad in their respect. I always show this picture in my presentations. These are all the partners of the Bloomen project. We have from Kender.io, Worldline, BMAT, the National Technical University of Athens, Deutsche Welle. I think I mentioned everybody. Without the contribution of all these partners, we would be able to produce something that we have today, that we have in a live environment. So we created 2 different tools for the users of the Bloomen Web TV. We developed a personal wallet. Actually, Worldline, project manager of the Bloomen Consortium, developed a mobile application that is available on iOS and Google Android stores. That with this personal wallet, you can have different types of dApps, named decentralized applications that you can perform daily transactions using either a common token or an independent token per dApp. And we would say that there's specific features that we like about this, such as there is honesty, there is no collection and sharing of personal data. The only thing we know about users is very brief information about their devices, and that's it. We don't know their names, we don't know anything about them, because really we are selling video content. There's no reason for a company to know many personal details of their users if it's just dealing with these amounts of very small amounts of money. Also, transaction throughput. For many that are familiar with blockchain technology, they know that blockchains have limitations in terms of transactions per second, but the environment we work on is based on Quorum. It's on the Alastria network, which is a public permission network in Spain with over 400 members. Immutability, of course, when you pay for content, anyone can see this, that you have a possession of the copyright to preview something. It's auditable. It's like a transparent database that anyone can go and see. And instant payments, of course, no counterparty risk because you can pay whatever you have as a remaining balance in your token. So the other party in between the two sides of the contract knows at any time that you can afford to pay for something without having to call your bank to establish that. Of course, users have full ownership of their funds. And private keys, because before we're talking about privacy, and this is something we explore within the project, we might give full ownership and handling of private keys to the users, but regrettably, this means that if a user loses their private keys, you cannot just tap forget password and we provide it to you. There's no way of doing that with such an implementation. The second tool we built is a web TV platform. This is very much like watching TV via the internet. You can access the platform on your TV, on your mobile device, on your tablet, and it's maybe meant to be running on smart TVs. And we are integrated this experience with a mobile wallet, so anyone can have an app on their TV that it doesn't mean that it's antenna app. Okay, our participation in the project is strictly for research purposes and providing our experience to the public and helping the whole sector thrive. But the idea is everyone has a smart TV app and they have their personal wallet, so they don't have to log in the app. They don't have to type with a remote control, but rather scan with the help of their mobile app. The wallet you can use to scan your smart TV, and this performs a cryptographic handshake between the mobile wallet and the app on TV. So it allows the TV to watch the content that this user has purchased before, or and the user can provide access to any of his devices. Really, we believe this brings new monetization opportunities, like something that Professor Yaglis mentioned before. Microtransactions is a thing that everyone talks about when dealing with blockchain and cryptocurrencies, and this brings a pay-per-view like as a unique key business opportunity. We talk about pay-per-view being really important for us because in the age of decentralization, you want to eliminate as many intermediaries as possible, and that means if you want to watch a boxing game or the Champions League final or like the latest movie that's out, you don't really have to have an intermediary platform offering that for you, let's say on TV, and making a deal with all these copyright owners and then just telling you, okay, if you want to watch all of these things, you have to pay 3-4 different cable TV providers and spend hundreds of euros just because you want to watch 3 separate things. So with peer-to-peer payments, this means that I can pay let's say the Primera División, there's possible copyright owner for the Spanish league, the football league, instead of having all these intermediaries. And this can prove to be more profitable for the copyright owners, as well as cheaper for the end user who wants to watch the content. It's also an ad-free environment. We're used to watching loads of ads online to watch content, and that's not something that people like. Finally, you can express your gratitude with the copyright owners. It's something we implemented as well. People can watch other people, independent creators, watch that create content, and they can tip them, they can send them these tokens. We name them Bloomen tokens, but really it could be any type of virtual currency. When it comes to our decision to use Bloomen token, we were really indifferent about this. I mean, if there was something like a central bank digital currency, like Professor mentioned below, by all means, we will use it because it's a more common, it has all the functions of money, and we don't have to reinvent the wheel as a company or like an organization. Let me see. So I have this on a live environment. This is our official website. As you can see, antenna.com.cy. We have a premium TV section, and this is like an alpha version of the integration with the Bloomen wallet. You can see here that the user has to scan with the device. Let me see if I can show also my phone. I have the Bloomen wallet on my phone. Oh, that's not good. Okay, zoom. Yes, I have the antenna, decentralized application, which I have 900 Bloomen tokens, as you can see up here. I can top up with a prepaid card. I can scan a prepaid card and top up. Yes, cancel. And you can also see I have a recent activity of my transactions. I can use this. This is like a scanner for either providing cryptographic handshake with your TV, or let's say my laptop here in that case. Let me see if I can do it. Hopefully it works properly. Yes. Okay, and yes, this is success. This is basically a zero token transaction, just to prove that I can allow this device. Then I proceed with watching content. We provided this Mexican telenovela. This might sound funny, why we pick this type of content, but I can assure there's a huge fan base of this type of content. And we provided this series before it airs on TV, so there's a huge interest. There's 700 people that registered to watch this type of content online, and approximately 20% of them actually went on to download the Bloomen app and do all this process. Essentially what you do is just click the series. If you didn't purchase it before, you have to purchase it now. And then because I have provided my handshake to the browser, it knows that I already paid for this content, and I can see the episodes right now. So back to my presentation. Who is our target market? As Bloomen now, and not really as Antenna. Copyright owners are see that users are lost between deciding which platform to use. Do I have to pay Netflix? Do I have to pay Amazon? Do I have to pay for everything so I can see whatever I want? Well, given that the market is estimated to go from 53 billion in 2017 to 113 billion in 2023, you know, that's a huge market here. We might be doing stuff on a research basis, but soon I think you will be seeing much more progress, like in a practical side of things. Typically, the users of our of the Bloomen Web TV is content producers, if it's be large production studios or independent creators, and of course the end users who want to watch the content. This is a question that was posed even during the reviews throughout our project, but also within the project, between the partners and the users of our. Yes, we believe that the government is a user, yes, because why? We have a virtual currency. This means that we're using a utility token and we want to reconciliate our transactions with fiat money. So because a virtual currency cannot do really anything with it since this is not legal tender. As Professor said before, previously, we also have to pay tax. You do transactions, then you have to pay tax. And just because there are certain levels of anonymity on blockchains doesn't mean that a business would go on about and perform tax avoidance. And smart contracts are offered by blockchain technology that can ensure accurate and timely payments to authorities. Is very important. Timely payments to authorities, and I will explain the next slide why. And of course, standardization. There should be some kind of alignment across the use cases of blockchain DLT in not only country but internationally, because interoperability, like Professor said before, is very important for this technology to thrive. And as I've said, the government is an actor, of course, and we kind of presented the key goals of Bloomen as a project to the tax commissioner in Cyprus. We showed how the mobile wallet and the platform works. We talked about the concepts. We talked about fair distribution of compensation, but and the main question was, okay, this all looks very interesting, but how can the government benefit from this? Well, as I said before, timely tax payments is a huge deal for the government. Just imagine paying for a product and the government receiving through smart contracts and digital currency tax immediately. They don't have arrears, they don't have to chase people. And this really, we're talking about lots and lots and millions, even billions, when talking about tax avoidance and all the issues that come with it. Finally, I want to say that really the Web TV use case could be a project of its own, like the other use cases of the project, whether it be the photo use case or the music use case. There's just like many things to consider for providing a solution to the world. Some of the things that we are exploring, not within the project, but also for future exploitation, is decentralized video hosting and rewards for the participants. So we are talking here about people and users being able to be content delivery networks themselves. So let's say Antenna has to pay a centralized content delivery network. They charge lots and lots of money. It's very expensive, mind you, to maintain, to offer video online nowadays through the content delivery networks. So we ask the question, can a user with high bandwidth connection at home offer to become part of our network for streaming the video to other users? We believe yes, and this is something that is explored by other initiatives and blockchains like the SIA protocol, and of course also blockchain-based encryption of video playback. The most prominent type of encryption nowadays is DRM, digital rights management. It's an agreement between copyright owners this is a technology that providers are using to ensure that the specific video will only be played to devices that are allowed to, and no one can steal that video out of private servers. And maybe with blockchain there might be a way to do this more efficiently and perhaps in a cheaper way. And better private key management, as I said before, is the question of who holds the private keys is a very interesting question. And another very important thing, very interesting thing is security offerings, monetization and tokenization of audiovisual projects and distribution of royalties. Think about producing a show. Think of the concept of you being a producer of a show and being able to tokenize this project. For example, issue like a certain amount of tokens, sell them, and through the proceeds that your film will make through the theaters, the initial coin buyers of this project will receive appropriate compensation. So it's like an investment. We had this with ICOs in 2017, but now we're talking about more official and more legitimate type of ways of tokenization. We see this coming in the near future. Professor, again, he talked about tokenization. And within this discussion, the token economy, let's say we use the Bloomen token now, but this is our own token. This is not reusable with other use cases, and maybe a CBDC, a central bank digital currency, there will be lots of things to benefit from if we use that. So thank you very much. Thank you all for sticking around. I mean, we've seen that most of the people were with us for the whole duration of the webinar. Now, what I will do is to pass on controls to our project manager, so he can say a last word and maybe and maybe direct the Q&A session if there is. Okay.
Okay, thank you, Michalis. So I do not see any questions from the audience, but maybe I can just make a very quick question first to you, Michalis. You have been talking about the challenges that you are facing in order to progress with this video platform. So what do you think that it may happen in the short term? Do you think that we will be seeing these kind of platforms around, or do you think that there's still some technical challenge that need to be addressed before we can see these type of platforms?
Nice question. So this is okay. This is not easy to forecast what will happen even in the short term, but I'm sure that because of the benefits blockchain technology offers, like peer-to-peer payments, like pretty much a liberation of an economy through tokenization, I see copyright owners, people like copyright owners, to gain much more power, like negotiating power in the market. So they will be able to come together, and all of them come together and offer their content through like something like a decentralized platform, a peer-to-peer based platform, so as to have, it's really more efficient and more economic for all the players in the market. So yes, I think I cannot say when, if it's going to be really soon or not, but there's really no reason why this shouldn't happen.
Okay, thank you very much. So hope we will be seeing this type of solutions very soon. And just a very quick question for the other panelists. It's just for my curiosity because I'm not an expert in cryptocurrencies, but I have heard a lot about quantum technologies that could be a threat for cryptocurrencies and for blockchain. So what's the situation right now, in which point we are right now in this?
Maybe shall I answer this or?
Yes, please, please.
Yes. So regarding quantum cryptography, I mean, we are still at very infant stages. Okay. So what is going to be like a danger is public key cryptography. So elliptic curve, digital signatures, and that stuff are going to really be broken, but not in the very like near future. And cryptographers are already working on like new alternatives. But whatever comes with like blockchain in terms of like immutability, transparency, and hashing techniques, all hash functions are pretty much secure. Okay, so they will withstand against like post-quantum attacks. But digital signatures are going to be problematic, which means that we can switch to new types of like post-quantum digital signatures, which are under investigation anyway, because NIST has proposed like a few of them to start studying in terms of security and performance.
Okay, thank you very much. Yeah, there is a question from the audience. It says, thanks for the presentation, Professor Giaglis. While there are clear benefits, there is a downside. The potential misuse and occasional thefts of accounts is worrying many non-technical people. So how long will it take for cryptocurrencies to stabilize and gain trust in the general public? What is your opinion? How long it might take?
Well, cryptocurrencies are about total ownership of one's assets. So the benefit of being the sole owner of your private keys needs to be counterbalanced against the responsibility that this entails. Because as Michalis said in his presentation earlier, if you lose your private keys, there's no I forgot my password button, and there's no recovery to be done by anyone. So for me, there will not be a mass adoption of cryptocurrencies unless intermediaries step in, like for example, banks or financial institutions, to offer custodianship solutions, because otherwise the cryptocurrencies will remain usable only by a small minority of the total market who is ready to assume the responsibility of being the protectors of your own wealth. So we need some time, and the time is dependent on when the market will step in and provide these solutions. This is a game theoretic situation in which the more people are looking into these things, the more providers will have an incentive to provide solutions, and the more providers provide solutions, the more users will be coming in. So it's a positive feedback circle when it happens, but we are not quite there yet.
Okay. Thank you very much for your answer. So I don't see any other questions. I don't know, Michalis, if you have something else to add.
I have a question about Theodosis regarding all these privacy techniques and cryptography. When it comes to research, these are, of course, people researching into the topic. But are these areas something that should business have in mind, or governments have in mind, or organizations? Like, for example, you co-drafted the national strategy for blockchain in Cyprus. How are you like applying these kinds of techniques on such a big organization like is the government?
Well, I mean, if you are mentioning for the specific techniques that I have applied, then these do not apply at the moment at the government strategy in Cyprus. But maybe they can apply it in the future. For example, if you would like to lead the securitization domain, It means that we need to be in position to carry out some transactions in a verifiable but anonymous way, which means that we have to apply these techniques. And this is not research at the moment. Most of them have already been implemented. So, I mean, these techniques are important whenever you need to verify transactions, but you don't necessarily have to leak information out, which is very important. I mean, we have GDPR now. We are part of the European Union, and they invest a lot in privacy and of their citizens. And this technique is the future if you want blockchain to be mainstream. Otherwise, we are going to come back to the problems like, is blockchain leaking all the information and that stuff? So they are necessary for us.
Okay. Thank you.
Okay. Okay, so I don't know if there are no more questions. I think that we can finish this webinar. Thank you very much indeed for the panelists, Professor Giaglis and Theodosis, and of course Michalis for moderating this webinar. I think it has been really very, very interesting. Have enjoyed a lot, and I hope that all the attending people has enjoyed as much as ourselves. Tomorrow we are having the first day of our hackathon. It's especially focused on developers of blockchain technology that intend to provide applications in the media sector. So if you are interested, I encourage you to register and join us. And in any case, thank you very much for this very interesting today webinar, and goodbye to all.